Today we're going to discuss compound interest. The formula for compound interest is A equals P 1 plus I to the exponent n. Now you might want to know what each of these numbers, each of these variables represents. Well, A represents the final amount of money that's in the bank account. And something I've noticed is that A can also, although technically this is not true, we could also say that A stands for after. In other words, A is the amount of money that we have after all of the compounding of interest has taken place. P technically stands for principal. That's the amount that was initially invested. But for our purposes, we could also think it stands for prior, because P is the amount of money that is in the bank or in the account prior to any investing in, interest taking place. Now, the little letter I stands for interest rate per compounding period. Okay? And in order to figure out the value of the little letter I, we use a table. The table might look something like this. Various compounding frequencies include annually, semi-annually, quarterly, monthly, weekly, and daily. There are others. And in each of these cases, I equals the annual interest rate, or the annual interest rate divided by the number of periods in the year. So if we're talking about an annual compounding of interest, little letter I will equal the annual interest rate. If we're talking about a semi-annual compounding of interest, little letter I will equal the annual interest rate divided by 2, and so on. If we're talking about quarterly, little letter I is the annual interest rate divided by 4. If it's a monthly compounding, we divide by 12. If it's a weekly compounding, we divide by 52, because there are 52 weeks in a year. And finally, if it's daily, we divide by 365. Something to remember about annual interest rates in this context is the acronym AIRHEAD. The annual interest rate has to be expressed as a decimal. We'll do some examples where you'll see that more clearly. Now, the fourth variable in our situation, remember, it says here, remember, AIRHEAD, 5% is 0.05. The final one in our formula is little letter n, which is the exponent in our formula. Well, little letter n is equal to the number of compounding periods, and in order to evaluate that, we often use the table. So if we are doing annually compounding of interest, well then our n will be the number of years. If we are doing a semi-annual compounding of interest, we will multiply the number of years by 2. Quarterly, we multiply by 4. Monthly, we multiply by 12. Weekly, we multiply by 52. Daily, we multiply by 365. And notice that the number that we divide by to get our little letter I will always be the same number that we multiply by to get our little letter n. It works the same way in each row. Okay, so in order to best understand this, it's usually a good idea to do some questions. So here's our first question. Question number 1. Timmy invests $2,600 at 5.2% per annum compounded quarterly. We'd like to know how much money will be in the account after 6 years. Okay, well, our formula, A equals P times 1 plus I to the n. We'd like to know what the letter A equals. Now, we know the amount that his principal, $2,600, this is the amount that was in the bank account prior to any interest occurring. But we don't know the letter A, the amount that's there after, so A is a question mark. Like we said, the letter P will be represented by the number 2,600 because that's the principal, or the amount prior to the interest occurring. Little letter I equals 0.052 divided by 4. 5.2% needs to be converted to 0.052 by moving the decimal place over 2 spots. We divide by 4 because our compounding frequency is quarterly, and because our table tells us that when we have quarterly compounding, we divide our interest rate by 4. And finally, little letter n is 6 times 4, which is 24. And again, we go back to our table, which tells us that when we have quarterly compounding of interest, n is the number of years times 4. Since we're talking about 6 years, we multiply 6 by 4. Now we plug them into the formula. A equals P1 plus I to the n. Well, we plug in our numerals. Now we have to remember BEDMAS. We're going to evaluate our bracket first. 1 plus 0.013 is 1.013. And then we're going to deal with our exponents. 1.013 to the exponent 24 equals 1.36341067 approximately. Now you might be wondering, why use so many decimal places? We do that because we want our final answer to be correct to the penny. We could lose marks if we're off by even 50 cents. So we carry a lot of decimal places just to be certain. We then get our final answer of 3,544.87. We round to 2 decimal places here. Why? Because we're talking about dollars and cents. So finally we can say that Timmy will have $3,544.87 in the bank after 6 years under these circumstances. Okay, let's move on to number 2. Question number 2 tells us that Amanda invests $3,300 at 4.2% per annum compounded monthly. How much will there be in the account in 2 years? Well, we don't know what A equals. We're looking for that final amount. But we know that the prior amount that was invested, the principal, is $3,300. We know that little letter I is going to equal 0.042 divided by 12 because we have a monthly situation and we divide annual interest rate by 12. 0.042 divided by 12 is equal to 0.0035. We know that n will equal the number of years times 12 because it's monthly, which is 24. And we know our formula, A equals P times 1 plus I to the exponent n. So we plug the numbers in, and our first move is to evaluate the bracket. 1 plus 0.0035 is 1.0035. We deal with the exponent now by raising 1.0035 to the exponent 24. We get 1.087469396. We multiply that by the initial amount invested, round to 2 decimal places, and we get $3,588.65. So we can say that there will be $3,588.65 in the account in 2 years.